Okay, children, now we will study about electrical capacitance of conductor. Electrical capacitance of a conductor. Now, by electrical capacitance, this means that it is ability to measure or to store charge by a conductor. How much a conductor is efficient to store charge in it. Storing charges means to transfer charge to it, because when the two conductors are charged, one may be at high potential, one may be at low potential. Okay, so but as we go on increasing giving charge to the body, when we give charge positive q to this conductor, say wire, then again when we bring some other more amount of charge to it, it will face some repulsion, so some work has to be done in order to store charge. So that's charge storage. When it is done, its potential also increases. That is, as we go on increasing the charge storing in a conductor, its potential goes on increasing. So q is directly proportional to v, or you can say q is equal to some constant times v. This constant is called capacitance. Children, what it is known as capacitance of the conductor. And basically this capacitance, it depends upon the shape of the conductor, size of the conductor, it depends upon the medium around it, around the conductor. Okay, and one more thing, it also depends upon the presence of another conductor in the surrounding. If some conductor is present near about, then also there is change in its capacitance. So it does not depend upon the nature of this conductor, whether it depends upon which type of material. It depends upon shape, it depends upon size, it depends upon the medium surrounding the conductor, this medium surrounding the conductor, and it depends upon the presence of another conductor. So it does not depend upon the nature or type of which conductor is made. So this much is clear to you. Now next we come the unit of this capacitance. Unit. Children, the unit of capacitance is farad. It is large unit, farad, and in symbolic form it is written in the form of F. So it is larger unit. So smaller units are millifarad, microfarad, and picofarad. Millifarad means M, capital F, which is equal to 10 to the power minus 3 farad. Microfarad is equal to 10 to the power minus 6 farad. And pico means pico, small p and f, which is equal to 10 to the power minus 12 farad. Children, generally when we do numericals, we get picofarad. About 20 picofarad of capacitor is attached here. That means you have to write, along with that value, you have to write 10 to the power minus 12, convert it into farad. So these things are very meaningful while solving NCERT questions. Next, after unit, we come across dimension. Now for dimension, see, q is equal to cv. So c is equal to q upon v. Q is charge and v is potential. So c is equal to q. In place of q you can write coulombs, and in place of v you can use its unit as volt. So coulomb per volt. This is unit of dimension of capacitance. C v to the power minus 1. You can write like that also. Now in 11th class you have studied dimensional formula. So I want all of you to find dimension of capacitance. This is your home assignment. you can do when you see, will watch this video. While watching this video, kindly do this also. You have to find the dimension of capacitance and then tell me in WhatsApp, so that I will clear. If you have any doubt, I will clear it. Next, I think this much is clear to you. Now we will come across the topic capacitance of an isolated spherical conductor. Capacitance of an isolated means it has been secluded and it has been kept somewhere where effect of other conductors or the other electric field is negligible. There is no effect of other charged or any field which is around it. Okay, it is isolated spherical conductor. So let us consider a spherical conductor. Say we will take this as a spherical conductor, okay, of say radius r, and this spherical conductor of radius r has been given uniform charge has been given, and it gets uniformly distributed everywhere. Uniform distribution is there, children. Then the potential. Now in order to find out potential of a spherical charge conductor, okay, this much you should be knowing earlier, because you have studied potential. Or I will remind you in this topic only, how you can find out potential of a spherical charge conductor. Children, the formula for potential is 1 upon 4 pi epsilon 0 q upon r. Q is the charge and r is the distance where we have to find out the potential. Now in case of a spherical charge conductor, if we take r to be at any point, say P, and r be at a distance this much, and this q charge is when we consider a shell, then we can consider this whole positive charge to be concentrated at the center. So q is the total charge and r is the distance. So potential will be 1 upon 4 pi epsilon 0 q by r. Now this q charge, which has been distributed toward along the surface of the spherical conductor, is same as it is inside. Total charge is q only. So when we have to find out potential at the surface, this was potential at point r. At the surface means at radius r, when r is equal to capital R. The formula becomes 1 upon 4 pi epsilon 0 q by r. Now potential inside the shell, it is also the same, 1 upon 4 pi epsilon 0 q upon r. Potential inside the spherical shell and potential on the spherical shell is same. It will be 1 upon 4 pi epsilon 0 q by capital R, the radius. So why it is same inside potential? It is constant everywhere because there is no change in the potential. So electric field is 0. Electric field inside shell is 0. Do you remember this? This is one of the applications of Gauss theorem. Children, in Gauss theorem we had determined electric field of a spherical shell. This was the third application. In that when we came across a point inside the shell, there was no charge, so electric field was 0. Electric field 0 means there is no change in the potential. Potential is constant. So we can say V inside is 1 upon 4 pi epsilon 0 q by r. As r goes on increasing, when it is moves away from the surface of the sphere, it again decreases and depends upon small r. So likewise we can draw graph also. See, suppose this is the shell, okay, and in this shell, this is the radius of the shell, okay. Till radius we can say potential is constant. This is the potential. I will use a different color for potential. See children, this is the potential line, 1 upon 4 pi epsilon 0 q by capital R. This is potential inside the sphere and outside the sphere. This is same, but as it moves away, as distance increases, then it goes on decreasing. It becomes 1 upon 4 pi epsilon 0 q by small r. This red line represents graphical representation of potential of spherical conductor. inside and on the surface potential is same, this much, and but outside it becomes this much smaller. So because in board examination they ask about graphical representation for this, for potential versus distance we get, for a spherical conductor we get graph like this. And for electric field, if we consider graph for electric field versus distance of a spherical conductor, suppose this is spherical conductor again of radius r, then for that if we take, again I am taking red, using this red, inside, see here electric field is 0 at the center, and inside this shell it becomes, it increases when on the surface it increases, so it boosts up here and then goes on decrease. So the main part is, for electric field line will be like this, graph will be this black for electric field, 1 upon 4 pi epsilon 0 q upon r square, and here it will be 1 upon 4 pi epsilon 0 q upon whatever you have got the formula for during when determining on r square during Gauss theorem. So this is graphical representation of electric field versus distance for spherical conductor, and this is graphical representation of potential versus distance of spherical conductor. So this was, the two things were very important from CBSE board examination. Okay, so again we will come back to our original topic. The formula for actually we are finding capacitance of a spherical conductor. This is spherical conductor of radius r, and we have to find out capacitance. Now in order to find out capacitance, let us consider potential at the surface. If q be the charge which has been uniformly distributed and this is an isolated, no effect of other charges, then v is 1 upon 4 pi epsilon 0 q by r. This is the formula for potential at the surface. Now q is equal to cv according to recent formula. Then we can write the value of v over here, 1 upon 4 pi epsilon 0 q by r, or this q and q both are same only. This, it was in the formula, so charge and charge will cancel, same charge you can write, use here q also, q is equal to q, so these two get cancelled and c we get 4 pi epsilon 0 r. So the children, c is equal to 4 pi epsilon 0 r, or this form. That means capacitance of a spherical conductor, capacitance of a spherical conductor goes on increasing with radius, or you can say with radius r, or you can say the size. As size increases means bigger and bigger the sphere be. Here the capacitance is C1, here the capacitance is C2, here capacitance is C3. That means C1 is less than C2, less than C3. C3 will be the greatest. Thus, as we go on increasing the size, the capacitance also increases. But this is, suppose if we want to have storage capacity, how come we can take a large amount of size? There is some limit to the size. So in order to find out another alternate solution to increase the capacitance, we find an arrangement that is known as capacitor. This capacitor we have to learn now. I will tell you in our next video.